Mr. Hiroshi Ohita will give us his analysis. Maybe you can give us in your analysis two information. Maybe you can speak about the surety of nuclear and also maybe about the problem of resources. Will we have limited resources, or with the new generation of uranium we will not have the problem of resources? Thank you.
Hi, good morning, everyone. My name is Prof.UJITA from Tokyo Institute of Technology. I belong to the Department of Nuclear Engineering, and my research area was the reactor safety, such as the risk analysis, human factors research, or severe accident analysis code development, and so on. I also belong to the Kano Institute of Global Study, where our research is energy demand and supply structure prediction in the 21st century against global warming. And I will explain the technical insight from the engineering viewpoint. So first of all, I will explain what I will discuss 5 issues. And first of all, I will explain what happened in the Fukushima Daiichi nuclear power plant. So magnitude of earthquake was 9 points, which is the 4th largest earthquake in the world. And all 15 plants located east coast of North Japan suffered the earthquake, while every plant was successfully shut down. Same as Kashiwazaki plant at west coast of North Japan suffered large earthquake in 2007. And every off-site power was lost completely at this time, but emergency power will still exist. And all plants were attacked by tsunami while observed tsunami highly. Only the Fukushima Daiichi site is slightly over the tsunami height is slightly over the ground level, which is higher than the design height. And but another plant is tsunami height is less than the ground height. So just only one site is suffered tsunami seriously. And as a total safety function status, plant was successfully shut down, but cooling and containment function were damaged due to the huge tsunami. So the INES, International Nuclear and Radiation Scale Rating of 3 major accidents are compared, and Fukushima was assessed by the Japanese government as the level 7. But the release amount is 1 order less than Chernobyl, even 3 units damaged. The reason why Fukushima and 3 Mile Island is less release than Chernobyl is due to their reactive control capability and fission product containment potential in the water. So there are many risk curves, which means a frequency consequence curve for severe accident compared by the OECD from the 1969 to 2001. So even the Chernobyl accident, of largest accident in nuclear field, the risk is very small than the other energy industries, 2 orders less than the other nuclear industries. And we cannot plot on that risk curve Fukushima or 3 Mile accident, because no fatalities, so no people deaths. The issue to be cared in near future would be the psychological problems such as post-traumatic stress disorder for the evacuatee as appeared in Chernobyl. Another large problem is a long-term problem as a soil decontamination or low-dose long-term radiation exposure or plant recovery. it will require 30 years for recovery of the Fukushima plant. So so accident causes, assuming such earthquake and tsunami, but not consider seriously such event. That is the root cause of the accident. So we should try to reconsider the safety concept, defense in depth. Defense in depth is the most important concept for their safety. Every kind of industries, defense in depth is the most important concept, and we should reconsider. And it's okay. So, root cause analysis is very important, but it's difficult to explain, so I will omit this time. And so I will discuss about what should be done to improve the safety. So defense in depth is most important. And so defense in depth is just, how to say, design concept. But another problem is operational problem, safety culture problem. We should, so defense depth is very important, but we should consider common mode failure, such as the earthquake and tsunami occur simultaneously or solve. That's a problem. And I will explain the energy issue after the Fukushima Daiichi accident. So premise here is that global warming and energy security is an invariant problem. So long-term energy demand and supply simulation to minimize the total energy system cost was conducted for energy production during 21st century in the world. So they are taking the effort for energy saving as major premise, carbon sequestration, and for fossil fuel, renewable energy, and nuclear energy should be altogether developed, which means the energy-based mix is required to be achieved under the CO2 constraint around 450 ppm atmosphere. So we have done the CO2 constraint case, and ideal energy mix is obtained. So well balanced between investment and fuel saving is achieved. So, and we also have done the nuclear phase out case scenario, and by the simulation, the contribution of the fossil power decline and nuclear power would also decline. So such place is mostly replaced by natural gas until around 2050, and by large-scale introduction of fuel cells since 2080. So nuclear phase-out scenario has two problems. One is increasing energy cost, as mentioned, IEA people said. And another is little room for countermeasure. It's very difficult to make countermeasure, and large uncertainty for their technology development. So nuclear phase-out case unbalance appeared between investment and fuel saving, and the burden is out on the developing countries increased largely. So therefore, rational use of nuclear power is requested. That is, each country should make decision. Japan and several European countries would be also phased out, while China, India, Asian countries will continue to seriously introduce nuclear. And
Mr. Ojito, sorry, please 1 minute.
Yes, okay.
You need to end. Thank you.
if the large accident happens again anywhere, it would become the global phase out in the world. So, therefore, rational unified safety standards, such as the organizational structure, design and operation and regulation form, such kind of things should be reviewed based on the Fukushima Daiichi problem, worldwide analysis, and established in the world. Thank you very much.